Alright, so this is example 2, finding the absolute max and min over a closed interval, because again, the endpoints are included. This is a simple rational case. Rational means division, because I've got this division here. Now, this works because the only part that this function doesn't exist at is 0. Well, 0 is not included in my interval. Alright, so the definition still holds. It's continuous from negative 1 to 30. And so that means I'm guaranteed, because it's continuous from not negative 1, continuous from positive 1 to 30. I'm guaranteed somewhere from negative 1 to 30, I will have an absolute max and an absolute min. It'll either occur at the 1 or the 30, or a critical value in between. Alright, so that's my first step, is finding the critical values. I'll change my color to blue. Alright, find criticals. Again, only between negative 1 and 30. This one's going to be an example where I have an extra critical I'm going to throw out. My derivative, well, before I start my derivative, I'm going to rewrite the 1200 divided by x as 1200 x to the negative first. Everything else stays the same. That way, I change the simple division to a power rule, so I can take a power rule derivative. Alright, negative 1 times 1200 is going to give me negative 1200 x raised to the negative 2. Then the derivative of 3x is 3, and the 10 zeros out. Alright, set it equal to 0, and when I set it equal to 0, I'm going to rewrite this. Alright, so again, set it equal to 0. This is, again, an important step, so always show that, because the rest of what I'm going to do from here on out is only true is if I set it equal to 0. Alright, I'm going to move the fraction to the other side, so I'm going to add it to the other side, so I get positive 1200x squared equals 3, and then I'm going to multiply by my x squared to get rid of the fraction, so 1200 equals 3x squared. You could solve this differently algebraically than I have. This is just the method I prefer. I think it's the simplest, so I get 400 equals x squared, take the square root. Remember, when you take the square root property is it's plus or minus. And so I get a negative 20 and a positive 20 are my critical values, not possible critical values. So I get 20 and negative 20. But remember, I only want the criticals between 1 and 30. So that's an extra one I don't want. I only want to keep the 20. That's the only one from 1 to 30. So that's the only one I'm keeping. All right, then the test. All right, remember the test. Since it's the closed interval case, we just find whatever the biggest y value is. So I take my endpoints and my critical point, only the one that I'm keeping, plug them into the original function and find the biggest y value and the smallest y value. So I plug 1 in, I plug 30 in, and then the only critical value I'm keeping is 20, because 20 is the only one that exists on the interval I'm looking at. And I can't actually do the negative 20 because, again, there's a break at 0, so 20 is the one I'm keeping. All right, so again, you're plugging them in here, the original, f of x. When I plug 1 in, well, I'm going to get 1200 plus 3 plus 10, so that's going to be 1213. When I plug 30 in, it's going to come out 140, and when I plug 20 in, that's going to come out 130, yeah. Alright, which means that's my max, because that's the biggest. That's my min, because that's the smallest number. Again, only over 1 to 30. Everywhere else they would have bigger or smaller values. But if I stay between 1 and 30, my maximum occurs at 1, it's 1213. My minimum occurs at the critical value 20, which is 130. Alright, so then writing that out, f of x has an absolute maximum of 1213 found at x equals 1, the endpoint. F of x has an absolute min of 130 found at the critical value 20. Okay, only over 130. The check then, so to graph it and check it. Alright, so there's my answer with calculus, and then you can always check your answer graphically. Alright, so again, I've got my graphing calculator. I've actually already plugged in the function. There's my 1200 divided by x plus 3x plus the original, right? That's the original function. I did adjust my window because using the values that I have, I'm only interested in from 1 to 30. So I like to make sure I see the big picture, so I see a little bit more. So I go a little bit beyond 30 and a little bit beyond 1. So I went from -5 to 40 so I could see everything. And then my minimum was at 130. My maximum was at 1213. So again, I like to see my axes, so I went down to a -5 and 1500. Right? That just allows me to make sure I see everything. All right, I go to my graph, and here's my picture. If I hit graph. And remember, I don't want everything that's showing up in this picture. I want to start at 1, stop at 30. So I find my starting and stopping points. So second trace, start at 1. Alright, so 1 starts there at 1213. Alright, second trace value at 30. 30 stops there at 140, which means at 20, and I'm going to put 20 in just to kind of gauge where it is. At 20, it should be at 130. So let's do second trace and just plug it in just to check. And so that's actually, again, it's hard to tell, but there's a little dip there. So there's a little minimum there at 20, 130. Okay, so now to put that picture in my notes. Right, there is part of the function on the other side of the axes that I don't care about. It's over here. I don't care about it. Again, I only want to start at 1, stop at 30. So at 1, it was the point 1, 1213. At 30, it was the point 30, 140. And then at 20, it dipped a little bit. That would be my 2130. Alright, so again, it comes down, dips a little there. I can draw. It's hard to tell, but it does come back up a little bit. That's my min. That's my max. Over, again, 1 to 30. Alright, only between 1 and 30, so it checks. That's the biggest. That's the smallest. This is just an endpoint. It's important because it's an endpoint, but it's not a max or a min. Alright, we'll stop there. We'll pick up the next one in the next